You shouldn't use CQRS. It might be a bold statement, but in this video, I'm going to explain why you shouldn't use CQRS, and I'm going to resolve some misconceptions that you have about CQRS. And eventually, at the end of this video, you will realize that when you should use CQRS and when you should not use CQRS. For those who don't know me, I am Fahad Alavi and I love talking about programming concepts. I'm not here to just write some codes for you. I'm here to teach you why we need to use something and, more importantly, why we shouldn't use something. If you want to be a senior developer, it is really essential to understand when and why you should use something. Let's start with some definitions and some clarifications. Usually we hear about CQRS, mediator, clean architecture, and sometimes, let me show it to you, domain-driven design in the same video, in the same book, and in the same concept. The reason that I didn't put this domain-driven design on the slide is that I forgot it. There is no other reason. Yeah, but CQRS is not related to mediator or clean architecture or domain-driven design. You can use them separately. Mediator is just a component. I created a video about mediator. I will put the link up in the right or left side, I'm not sure. And you can just see it. And this one, clean architecture. Clean architecture is a structural architecture, exactly as CQRS. CQRS is an architecture as well. And if we want to talk about domain-driven design or DDD, I need to say domain-driven design is a design. It is mostly the way of thinking about how to address the issue, how to find the solution, and how to create one unified language that business analysts, business owners, and developers can understand it. You know, there are 4 different concepts. But I don't know why, mostly in most of the videos, when they are going to explain any of them, they jump to explaining all of them together. And by doing that, no one explained any of them separately. Let's do it. Let's talk about the history of the CQRS, because CQRS came for the separation of concern. History of separation of concern. Broader architecture pattern. In 1980s, developers started thinking about it is now time to separate the concerns, and separate the concerns should start from the way that we are putting the files in the solution. What do I mean by that? At that time, we had just monolithic applications, but they started thinking about some other patterns and architectural patterns like multi-layer applications, like MVC or MV star, if I want to put it in a better way, because we have MVC, MVVM, you name it. And in 1988, the concept of CQS introduced. CQS and CQRS are 2 different things, but they are here for solving one single issue: separation of concern. CQRS suggested to separate the logic between reading and update, delete, and adding new data to the database. When I'm talking about database, at the time we had relational database. And by relational database, I mean something like the SQL Server that we use today or Oracle that we use these days. And we had service-oriented architecture. Eventually in 1990, the idea of service-oriented architecture introduced. Service-oriented architecture is a grandfather of microservices, which means that we should put each of the concerns, business concern, data access layer concerns, or presentation concept differently in different projects on different servers, and they should call each other using services. And almost at the same time, the concept of virtualization helped us to do that. Keep it in mind, at those times, the cost of hardware was really high. You know, it was really expensive. If we had a problem, if we had a performance issue, the product owner hired some other senior developers to address it, because adding more memory or CPU or hard to the servers, the cost of doing that was way higher than hiring a senior developer. And the only scaling option that we had was scaling up, which means that we had a server. We need to add more RAM, more compute processes, or more memory, or more storage to that, or do it more and more. And the limitation of servers, for example, at the time, we had servers with some slots for new memories or hard drives. And if we wanted to add more memory or CPU to a server at a threshold, we needed to add another server, and we needed to wire the servers together to work together. And it was really time taking. It was really heavy infrastructure process, and it was really costly. Let's see what happened in 2008. 2008 is the year that I started working as a full-time .NET developer. Around that time, the idea of containerization came in place. And by containerization, we switched from scaling up to scaling out, which means that we could add more servers and put a load balancer in front of them. And by doing that, we just separated the load between different servers. I guess it was 2009 that event sourcing introduced. If I want to explain event sourcing, you need to think about the way that we are storing data. The way that we store data in traditional databases was like that. We had a field and the value. As an example, we have a name, laptop, and the quantity of the laptop, we have 15 of them right now. If we change something, if we update this row, the value here changed like that, 10, because we sold 5 laptops. And if we ordered from the main branch to send us some more laptops because we are low in stock, we just store the 25. But what is event sourcing? Event sourcing is a way of storing data, which we store different stages of the data or different states of the data. We have a table. We have field, value, and action. It is not 100% correct. I'm just trying to explain the concept behind event sourcing. And it has an action. They are initialized value for quantity and name. And if we sell 5 laptops, we will add another row here with the action, which is sold. Now, at this stage, if we want to know how many laptops do we have in the store, we need to find all quantity fields and add all the values together, which is 10, sum of 15 and minus 5. And if we add 15 more to them, now we have 25 laptops in our database. Can you see the process for adding and the process for reading files are really different? We have some business logics for adding, and for reading, we need to do a lot of things. We need to convert the data. We need to do some queries to just find the result. And because of that, CQRS introduced in 2010. Maybe it is not really accurate to say because of that CQRS introduced, but the time that they introduced right after each other, to me, it is a bit suspicious. And we had microservices in 2012. Microservices and CQRS usually come hand to hand. If you want to explain CQRS, it is better to explain CQRS using microservices or Kafka instead of using a CQRS using clean architecture and mediator. Let's go to some definitions. We have CQS, command query separation, and CQRS, command query responsibility segregation. The first one is a behavioral design pattern. CQS is here to tell you inside your application have some classes for insert, update, and delete, and have some other classes for querying and just receiving data. And in those classes which are for command, by command I mean insert, update, and delete. In the command classes, you shouldn't query anything from database. And in query classes, you shouldn't use any insert, update, delete, and manipulate anything inside the database. But CQRS is a broader architecture. In all demos that you saw online, they are treated it as CQS, as a design pattern, not as an architecture. CQRS suggested to have command and query separately in architecture level. There is a difference between architecture, design, and design pattern. One of them is architecture level, the other is design level. Let's see the problem that we try to solve using CQRS if we are not using event sourcing or messaging. Okay, the problem. We have a user. The user is going to send some request and get some response from our application. We have a presentation layer, we have a business logic layer, and we have a data access layer. We have a database, which is a relational database. The reason that I put PostgreSQL icon on the database is that the icon for MS SQL and Oracle didn't match my design. And we do add, update, and delete, and we receive queries from database. Now that we realized what is our structure, let's see the problems. This is the list of the problems. The first column is my command, and the second column is my query. For command, I need validation, and I need to put validation here and here for everything, literally everything. But for query, you really don't need to have validation. The type of the object that carries my values and carries my data for command is entity. Entity is something like a map between exactly the table that you have in database and a class in your application. But for query, we usually go for DTO. DTO is something that you need to map again to entities because it is more complex. As an example, in database, in relational databases, we store so many keys and foreign keys. We are not going to present the foreign keys to end user. We are going to get the value of each relation and show them side by side. For command, we don't need mapping usually, but for query, we need mapping. For the performance, for add, update, and delete, I need to have a normalized relational database. But for query, it is better to denormalize the data and flatten it because it is faster. And relational database are better for command, and NoSQL and non-relational database is better for query. Imagine we have a system like Amazon or like Booking.com. Are we changing data a lot? No, maybe they sell 1,000 items or add, insert, or update 10,000 items in their database every day. But so many people read data, so many people scroll, so many people search, so many people request for a query. And I can say the load between command and query is not the same. Then you need to scale them separately. You need to scale query maybe for 10 times, but you need to scale the command maybe 2 times. And based on my experience, there are some other hassles that you face in these scenarios. Database locks. When you are reading or writing or updating, intentionally or unintentionally, you are putting some locks on the database. And when you are going to access a data, a row concurrently, you will face some delays. Event sourcing. For event sourcing, using relational database is a nightmare. And if you want to use messaging systems, if you want to use Kafka or things like that, using traditional way of treating insert, update, delete, and querying is not a good idea. And independent scaling, as I mentioned, you need to scale command and queries separately. In this video, I'm going to use a lot of sentences or points from Microsoft website or from Martin Fowler website. And this is one of them from Microsoft website. They said that in many cases, there are so many concurrent requests on the server or parallel requests for the same set of data that can have a negative effect in the traditional way like n-layer application. And for handling the security and complex permission levels, separating the command and queries are better because mostly we have more security related to commands than queries. What is the first solution? The first solution is like that. We have exactly the same system. We have the presentation layer. We just separate the business logic data access layer from the command and query, which means if I have a repository for command, the repository should just set something, should just write something or manipulate something on the database. And the query repository should just be able to read it. And the business logic for the command and business logic for query should be splitted in two different projects. If you are not splitting them physically in two different projects, it is not CQRS, it is CQS. This is the first one, but it can help me to some extent because I can scale it up and I can scale it out separately. Okay, good. But the issue that I had about the performance normalization of the data, about SQL and NoSQL, the different format of the data, which is good for each command and query, how to address it. Then the better solution is to have presentation layer, have business logic layer, and data access layer. For command, it is better to use a relational database because we need to store the data normalized. And we need to have a service or something in between. I'm not going to talk about that, but there might be some other actions after storing a data on a database. Some other events may be called. Those events may start transferring the data or doing some ETL processes on the data and create some other denormalized document-based data for you. By document-based, I mean NoSQL data. And this is the MongoDB icon, I guess. It is one of the most popular NoSQL databases that we already have. But we need to have two databases. We need to have a process in between, and it comes with a cost. The read, the query is not really real time because it takes time, maybe up to a minute, to read everything from database and put it to the read-only database that we have. Now that we understand what is CQRS, it is time to address what are the problems of CQRS. First of all, implementing CQRS is time-taking. It increases the complexity of the code. If you are using CQRS for messaging-related scenarios, the failure of a message, the duplication of the message, and if you have message with priorities, implementing CQRS is literally a nightmare. And the consistency. One of the benefits of CQRS is for the time that you want to split the different concerns between different teams. As an example, you may have a team for create query and another team for creating a command. They are working on two different and separate projects and code bases, and they can push them to server separately. Okay, good. It is a good thing. But what is the issue with consistency? You are not working on a model. You are not working on a single database. You are working on two different models. You are working on two different databases. Managing the consistency between the data that you have in each of these projects will be a bit hard. Well, CQRS has some problems. CQRS is here to help us for some specific scenarios. We know where and when to use it, but when not to use it. It is the most important question that we need to answer. CQRS is not for you if the domain or the business rules are simple. I can guarantee that in 75% of all projects around the world, the domain and business rules are literally simple. Simple CRUD style, create, read, update, delete style user interface and database access operations are sufficient. I can testify more than 95% of the projects in the world can use simple CRUD operation. These 2 points, I just brought them from the Microsoft learning page about CQRS. And let's see what Martin Fowler believes about CQRS. Despite the benefit, you should be very cautious about using CQRS. Wow. Many information systems fit well with the notion of an information base that is updated in the same way that it is read. Okay, then Martin Fowler approved that a high percentage of application can use simple crowd operation. Adding CQRS in such systems can add significant complexity. Significant complexity. You don't want to add it to your system. I have certainly seen cases where it's made a significant drag of the productivity, adding an unwanted amount of risk to the project, even in the hands of a capable team. I guess it is obvious. CQRS is not for us. CQRS is just for some specific scenarios. And let's see what he says after that. So while CQRS is a pattern that is good to have in the toolbox, be aware that it is difficult to use well, and you can easily chop off important bits if you mishandle it. Okay, if it is that hard, if there are so many issues with using that, why we want to use it? Because it is just trended? I'm not sure. And the last question, I want you to think about that and let me know in comments. Are you using CQRS by the definition that I gave you, or you are using CQS? Are you separating the command and query in two different projects? Or you are just creating command and queries in different folders? If you are putting in different folders, how can you scale them independently? In most of the videos that you see online, on YouTube, or even paid trainings, they are using CQS instead of CQRS. I'm preparing a series of videos about .NET, in depth about .NET and clean architecture and domain-driven design. And in those videos, I'm going to use CQRS and CQS. Please just let me know by writing down in the comments if you are using CQRS or CQS. And if you had a misconception about CQRS and mistakenly used CQS instead of that or not. Let's go to Visual Studio and see how a simple CQRS application works. I guess you can remember the previous project that we created for Mediator. I made a copy of it, put one copy for query and another one for command. For those who didn't see that video, I'm going to explain it a bit. I have house hunting query API, house hunting query business, house hunting query DAL, and house hunting query model. It is 3-layer application. It is not clean architecture. In API, I have a controller, and in controller, I am just getting houses and getting houses by budget. I'm passing a budget and use Mediator to send a request to the handlers, and handler is going to handle this one. Let's go to the business layer. Inside the business layer, I have my services. In my services, I'm just calling the repository, and in the repository, I'm just getting the house and getting the houses async. It is just querying. It is not storing anything inside the database. I have a folder for request. I have one request for get house and another one for get house by budget. I'm explaining CQRS using Mediator right now, but you don't need to use Mediator at all. You can directly from your API call your business without having Mediator in between. And inside the handlers, just calling the service get houses and calling the service get houses using a budget. And if I go to the data access layer, in the data access layer, I have one property for houses. I am filling in using some data. In total, I have 4 houses. And returning houses based on the condition or all of the houses. Let me open it and test it. Let's see all houses. Yes, I can see I have 4 houses here. There are some extra information here. The reason that I have it is I'm just returning the Mediator result directly here. You can filter it by changing the code like that. Let me see, go to the API, handler, and here just adding a result. If I can write down result, and let me go back here and try it again. Now you will see that it is just returning my data. And for data by budget, let me try to say just 2,000 euros. And it is working fine. I have another project, and in the other project, I just separated the command, which means just adding house, updating house, and deleting house. Let's see how it works. I have exactly the same copy of the structure inside the API. I'm accepting add house with house items. I have one add house request, one update house request, and one delete house request. Let's see how they work. Let me go to the business layer. Inside the business layer, I have service registration. I have services. I have services. And in services, I'm just calling my repository as it was for the query project. In configuration, I am registering my services here, and I'm registering the mediator. For request, I have add house. Do not look at these things. I'm going to explain about them later. Adding a house, deleting a house, which is a record, and updating a house, which the request type for all of them, the return value for the request is unit. Unit is a specific type that mediator created for itself when you are returning void for a request handler. And inside the request handlers, for add, I'm creating a request handler for add house request. It is void, then it should return unit. As you can see, I'm returning unit here. I can do it like that because I'm receiving a house and I need to, I'm receiving a request and I need to convert it to house. I can create a house object and after that pass the house object, or maybe I can think a bit smarter. I created one base house request. This base house request has all the properties that I want because the properties between adding a house and updating a house are almost the same. Update just has ID. We don't need ID here. And I have one constructor. The second constructor accepts house, which means that we can create a request object by passing it the house, and it is just putting all the properties together. You can use mapper for doing that, but I'm not going to introduce more and more components and dependencies here, just to explaining the CQRS. And with get model, it is converting this request to the model. And as you can see, it works like that. And there is a thing here. Inside DAL, I have repository and iRepository. I still have my static object here for storing the data. It is really hard to implement two different databases for command and query. And even if you implement that, the ETL, the data conversion loading from the command database and create the query database, it is time taking, and it is something that I'm not going to address in this project. Then I am just using these two different objects on the memory. Let me wrap it up again. In command, we are just saving something onto database. And in query, we are reading something from database. In CQRS, it is better to have two different databases. One normalized database for command, let's call it command database, and one denormalized database for query, let's call it query database. Here, you can see that I have one API for command related request, and I have another API for query related requests. Here there is a tricky point. If I want to add something to my database in the command part, sometimes I need to read something from database. In my example, because I'm writing and reading to one object in my repository, I need to read all the objects inside the list and find the biggest ID, add one to the ID and create new ID, because I don't have any other options to implement identity. In real life projects, you may face things like that, and you need to compromise between the concept and the structures that you have, because sometimes you need to read something from database. If you want to do that, you have to use query APIs. Or if you want to read something from command database, you can do that, but try not to spoil this concept. As you can see, just by introducing CQRS and CQS to your project and to your architecture, the level of complexity increased and maybe doubled or tripled. Then you need to know where and when to use it. And as a senior developer, you need to know why you are using something. What are the benefits of that? And if you don't know that, it is better not to use it. If you like to know more in depth about .NET and architecture, just subscribe to my channel and like this video. By hitting the bell, you will get notified after I upload another video. Thanks for watching this video and enjoy your life as a developer.